What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. In this video, we're continuing on with our wireless overview, and now we're going to go over antenna fundamentals. So another key component in our wireless LAN networks is going to be the actual antenna that allows us to actually radiate the waveforms, right? That lets us actually propagate that signal out. Because without a proper antenna, and without the ability to send our wireless signals, we cannot, radiate a room where our Wi-Fi enabled endpoints can actually connect to our access point. So the first thing we're going to go over is going to be how antennas, or how we view antenna signals. So what we mean by that is, imagine we have this diagram, kind of like a physical diagram of our office. And now we're the network engineers that are going to have to deploy access points for all these users. Well, we got to kind of figure out where we're going to place our access points and where the radiation patterns are going to be, where they're going to be strongest and least strongest, and do we have good coverage in our office for all of our Wi-Fi enabled endpoints and users. So the first thing we're going to talk about is the H-plane. This stands for horizontal plane. And this is going to be a bird's eye view of the actual access point's radiated signal. So imagine we put an access point here, and it has an omnidirectional antenna, which we're going to go over, but essentially that means that it radiates 360 degree radiation of our Wi-Fi signal. Well, so we'll maybe see it come over here, and then as it gets towards the edge, it gets weaker and weaker. So as we see it from the bird's eye view, that's going to be the H-plane. And typically the way you see this when you actually use like heat maps is you're going to see like maybe like dark green towards the center and then light green as you get out. And that's kind of like the software you use when you use heat map software and you actually do your little site survey. That's typically what you want to see. And another thing to consider here, right? So on the topic of H-plane, and we're going to go over E-plane, is a site survey. So typically when we build up an office and either you're part of that MSP or the IT team that's either going to deploy the network services for a new office or a brand new company, what you want to do is a site survey. So you kind of want to go to the building, look at the rooms, see where the thick walls are, what material they're made out of, and then start implementing like kind of like dummy access points. Essentially an access point that you're going to turn on that's going to send that 2.4 or 5 gigahertz signal, and then you're going to want to do a map it out. So go from edge to edge to edge with your like Wi-Fi heat mapping software and technologies, and kind of build that site survey. Okay, when I put an access point in the middle, omnidirectional, it can reach this user in this office. But typically it's done when everything is empty. So you're going to have to take into account, file cabinets that may be put in place. These cubicles that get put in place. So what material are they made out of? Are we going to get that degraded signal? Kind of how I showed you the signal comes into a wall and then gets smaller in its amplitude or its power. So just something to think about. And with the H-plane, you kind of don't always get that full view. You just get that horizontal view. So if there's access points on the ceiling, you may see that their signal does reach over here, but does it actually reach to that desktop that may be sitting below this desk? And that's where the E-plane comes in. So the E-plane is going to kind of look at that signal kind of like in a almost vertical instead of horizontal. So let's say this is your desk and this is the desktop down here. Here's your little monitor. In the E-plane, we're going to look at the signal this way, right? And how it comes in here. Kind of looking at it almost from like a side profile. Whereas horizontal is that bird's eye view. So that's the difference between H-plane and E-plane. And the reason we talk about this, because a lot of this has to do with antennas. So we always talk about the access points, but really access point placement is really when we're talking about Wi-Fi signal strength and where it radiates to, we're kind of talking about antenna placement. Because I can put an access point up anywhere I want, but depending on what kind of antennas that access point has, whether it's omnidirectional, unidirectional, what kind of antenna gain it has, really depends on the placement. So like an example of this, and let me bring my face back into view, or literally the camera back into view. If I show you this, this is a Cisco 3702 AeroNet. So if I read the back here, I know obviously you can't see it, but it says 802.11 AC, which is Wi-Fi 5. We're going to go over that dual band access point. So I can look into the specs of this access point and compare it to my other access points, which I don't have laying around, which is my 3800 series, and see which antennas are stronger and if they're both omnidirectional. Because if they're not, and I do a heat map using this, and then all of a sudden we put in a 3800, well, those radiated signals are going to be different because this may provide more power. It may have different antennas than an actual 3800 series. And that goes for any access point with any vendor you're going to use. But we're CCNA, so of course you're going to use Cisco Wireless, right? Okay. So now we've kind of gone over the H plane and E plane and when you need to know these terms, when you're doing your heat maps and your site surveys. Let's go into what's called the EIRP, and that's the effective isotropic radiated power. So this is how powerful the signal is when leaving your antenna. So what we mean by this is what is the total, I guess, dBm, right, or strength when it leaves. So every antenna has a different EIRP rating. And what that means is, like in America, the FCC says 36 dBm is the total strength you can do for Wi-Fi. You can't go stronger than 36 dBm. So antennas will have an EIRP rating saying, okay, this antenna can do up to 50 decibels, or this antenna can only do up to 20 decibels. And then if it's directional, or unidirectional or omnidirectional, that's also going to change in how it kind of, the antenna manufacturers put out its EIRP. So to find out what the effective isotropic radiated power is, what you're going to do is look at the transmit power of the transmitting device. So I say that because it doesn't have to be a Wi-Fi access point. This can be in a ground station antenna. If you guys have been watching my videos, you know I come from a SATCOM background in the Army. So when I was like teaching this wireless section, I'm like, man, I learned this during my initial training in the Army, but it was for ground station antenna shooting to geosynchronous satellites. So the transmit power source, and in our case, is a Wi-Fi access point, but it could be anything. So let's say we have an access point that is transmitting at 25 dBm, meaning you go in there and you say, hey, access point, I want you to do your max strength, and maybe that access point says I have a max strength of 25 dBm. And a lot of this depends on how much power it's actually getting. So some access points require like really strong PoE switches, but not to get sidetracked. So that transmitting source, right, transmit power. And then we have a term called antenna gain. So what that means is when someone manufactures an antenna, the reason we're building that antenna is so we can actually get this power out. Because imagine you have all this energy that you're building up even as a human, and you can't do the push-ups or go run to get that energy released, right? You're going to explode. Well, an actual antenna for the access point is the same way. This is how we get the signal out. This is how we get the energy out to create Wi-Fi signals. So antenna gain is how much stronger we can make that Wi-Fi signal through our antenna. And typically you're going to see big antenna gains for unidirectional versus omnidirectional. But of course, if unidirectional, it's only going one way, whereas omni is going 360. And then you're going to have to subtract any sort of cable loss. So when did this come into play? Because if I bring my camera back over here, let's bring my access point back into view. Where do you see the antennas on this? You don't, right? Well, that's because they're internal. So if we were to open this up, and I think one of the bonus videos we will open up an access point and look, you're going to see that 2.4 gig, 5 gigahertz antennas. And that's another thing. Antennas are rated for certain frequencies as well. So if we're talking high frequency, ultra high frequency, we're gonna have antennas built for each one, and they're gonna have different ratings. Um, and the bigger the range of an antenna's accepted frequencies that it can transmit, kind of the weaker the signal can be. And we're not going to get into that. Again, my SATCOM background, I just don't want to get too deep. But you see in here, there is probably no cable loss when we're talking antennas in this access point because it's all internal, and that antenna probably just sits on like the board of this access point. However, if we have a directional antenna that is like on the outside of our building and there's like a coax cable all the way down to, let's say, maybe an actual access point or maybe a wireless LAN controller down in our comms closet, there's going to be cable loss. There's going to be attenuation depending on how long that cable is and what that cable is rated for and keeping a signal strong, keeping a signal intact. So there could potentially be cable loss, especially if the antenna is separated from the access point or the actual transmitting source. So that equation brings us to our total effective isotropic radiated power. So your transmit power plus your antenna gain measured in dBIs minus whatever cable loss or attenuation you may have on the cable that's connecting transmit source to antenna, that's going to equal your EIRP. Okay, and then let's go over actual different types of antennas now. So we're just going to go over a few different ones as it relates to Wi-Fi, because again, I mean, if you really want to talk to like, I call them ham nerds, but ham radio operators, there is a lot of different antennas out there, and they all have purpose-built, they're all purpose-built, right? But as far as like access points go and what you're going to see in a typical deployment in an office building or a multi-office compound, you're going to see omnidirectional, directional antennas. There's something called sector antennas that kind of, if I were to put it on a chart, right, they're taking this sector, and this sector for their unidirectional Wi-Fi signal strength, and then leaving this kind of empty. We're not going to get into those as much because, again, as a CCNA, you're not that wireless engineer. You may just be helping with some of this stuff. So we got to know the terminology. So kind of self-explanatory. In a directional antenna or unidirectional antenna, what you're going to have is a strong Wi-Fi signal in, again, one direction. So this could span, if we have a 360 degrees, that direction could span maybe 45 degrees of that segment, right? But essentially the point is to the back area and the side areas don't get any signal. And you may get some little lobes here, and that's just like what happens sometimes when you push out. Signals sometimes go this way. But the whole point of a directional antenna as far as Wi-Fi goes, let's say you have like a parking lot out here and you want to make sure that nobody can park in your compound's parking lot, the public space, and connect to Wi-Fi signals. And let's say you have this office building here. And if you put a omnidirectional antenna, let's say right here for the users sitting here and here, right? Put their laptops. Well, that signal may reach out to the parking lot, and then we can maybe like be susceptible to what's called an evil twin attack or rogue access points. Well, what we can do in this scenario is we can actually put in a unidirectional or directional antenna. And by doing that, by putting that unidirectional antenna maybe on the wall here, we call that like a patch antenna or a patch access point, placing it on the wall instead of the ceiling, we can just send the signal this way. So then that backblast area is maybe going just a little bit past the wall, but no one out here in the parking lot or anybody walking by can look at our signal. And then of course, with omnidirectional, those are going to be the access points you see in every typical office deployment. That's going to be probably center of the room, trying to reach the entire office floor, maybe that one building. Omnidirectional antennas are typically what you're going to see in the house. And this is typically what you're going to see when you're doing deployments. Just wanted to show you another common directional antenna. Sometimes here, if you have a compound and you have these two offices here, you may have these directional antennas sitting here, actually sending signal back and forth. Maybe if you didn't want to dig up the ground and run cable underneath, or maybe this is just a redundant form of communication between this campus network, that's another directional antenna that you may see as part of your wireless deployments. Okay, so that's going to be it for this video. Stay tuned for our next video. We're going to go over wireless LAN controller or wireless area network frames. So how does our actual Wi-Fi enabled endpoints and our access points talk via layer 2? So thank you for viewing. And again, if your unit or organization ever want in-person training or live virtual training with Trepa Technologies, please hit the link below, go on our website, reach out to us, see if we can come to your organization and get y'all certified. Thank you.